Okay, so good morning everyone. Today we are discussing our practice paper 20, okay, for 2027 A-level batch. So in this paper, we have 12 MCQs and one essay question I selected from the past papers. It is from Chemical Calculations, 2023 A-level past paper Chemical Calculation essay. And then we have a structured essay question. Okay, so this structured essay question, the marking scheme I led after the class. So you can mark your answers with that marking. And it is that structured essay is from just unit 1 and unit 2, that usual structured essay that which was earlier we had done several questions. Then you can mark that. Okay, so we will discuss that essay question and 12 MCQs with the class. Right, this is your question. So shall we read it carefully to understand what is given in the question, right? So it says like this: a solid sample X contains P and Q and an inert substance. Okay, and this P is a substance with the formula Fe2O3. Okay, we call it as ferric oxide, and the Q is a substance which is the formula Fe3O4. Right, so they describe about this Fe3O4. It says it's a single compound which contain Fe2 plus and Fe3 plus. Okay, so iron existing two oxidation numbers, and then there is a reaction given how this Fe3O4 reacts with I minus in order to give Fe2 plus and I2. So it's a redox reaction. You can see I minus has oxidized from I minus to I2, minus 1 to 0. Then someone has to reduce. That means the compound, in that compound, Fe3O4, you have Fe2 plus and 3 plus both. No? That Fe3 plus has reduced from plus 3 to plus 2. Okay, so that's what has happened in that equation. Actually, they have given it. So you don't need to balance it. Okay, it's a balanced reaction. So what you need to understand is 1 Fe3O4 gives you 1 I2. Isn't it? 1 Fe3O4 gives you 1 I2. Then look at the procedure. It says the following experimental procedure was used to determine the mass percentage of P and Q. Okay, P and Q are the two compounds. So then it says when 3.2 grams of sample X was treated with excess Ki, okay, and in the presence of dilute sulfuric, all Fe3 plus in it was converted to Fe2 plus, liberating with the liberation of iodine. Okay, so the resulting solution was diluted to 100%, 100 cubic centimeters, which is labeled as X, S, right? Then to convert the iodine into iodide, in 25 cubic centimeters of the solution, 15 cubic centimeters of 0.5 sodium thiosulfate was used. So now it's kind of a long explanation. So I'm going to break it down for you, okay, with a diagram. Okay, so I'll put these details in the board. So after that, we will come to the remaining part of the description. Okay, so let's first of all understand what is meant by that initial part of the question. Okay, so it starts like this. There is a sample called X. In that X sample, you have Fe2O3 and you have Fe3O4. Fe3O4, and there is some inert substance also. So it is a combination of three compounds. So we are taking 3.2 grams of that sample. 3.2 grams of that sample. Okay. And it explains about this Fe3O4. I'll explain that too. Now, this Fe2O3, we call it as ferric oxide. Ferric oxide. That's the trivial name. But the IUPAC name is iron 3 oxide. Iron 3 oxide. Okay. So Fe2O3. That means in this compound, you have iron in oxidation number of +3. Then there is another compound, Fe3O4. Fe3O4. Actually, it is a combination of two compounds, right? And we consider it to be a single compound. But actually, this is formed by FeO and Fe2O3. So let's add them and see whether that is true. So then it becomes Fe3 and this becomes O4. That means within this compound, you can assume you have FeO and Fe2O3, both oxides of iron is there. So this is called as ferrosoferric oxide. Ferrosoferric oxide. Ferrosoferric oxide. So you don't need to know the names, but actually just understand Fe3O4 is a very good question. The only it haven't asked in the past papers, right? Only this time they build a question on this, right? So Fe3O4 is ferrosoferric oxide, which composed of both iron oxides. Understand that, right? Okay, so then this compound has both iron atoms, ions, Fe3 plus and Fe2 plus, both are there in 1:1 ratio. 1:1 ratio. Okay, so that's what you need to know about the compound, right? I hope it is clear to you. Right, then what they're doing is they're adding this one with excess Ki in dilute sulfuric. Okay, that means we are reacting this one with I minus. We are reacting this one with I minus. Then as a result, all the Fe3 plus will be reduced to Fe2 plus. 3 plus will be reduced to 2 plus. And I minus will be oxidized to I2. This is the reaction happening. Okay, this is the reaction happening, right? And then this sample is kept in 100 cubic centimeters. After diluting, it says they convert this one into 100 cubic centimeters, which labeled as S solution. S solution. Then they take 25 cubic centimeters of this solution and react that one with sodium thiosulfate, Na2S2O3. Sodium thiosulfate. Okay, so from sodium thiosulfate, it says 0.15 moles of sodium thiosulfate, so 0.505, 0.5 moles of mole per decimeter cube of sodium thiosulfate concentration, and 15 cubic centimeters has reacted. Now here you have within the solution I2. So it's reacting with I2. Understand? It is reacting with I2. Then we can identify the I2 moles now, right? And then it is telling they take another sample. So I didn't show you that part, but just you can understand. After taking another 50 cubic centimeters. Now this one was 25 centimeter cube. Okay. Now here it is a 50 cubic centimeter sample. That is another good thing they did in the question. Okay. So they took separate samples. Okay, separate samples of different volumes. That's a good thing, that advanced feature. Okay, so then it's 50 cubic centimeters. It's reacting with KMnO4. KMnO4, and from KMnO4, concentration is 0.25. Volume consumed was 14 cubic centimeters. Now here, when it is reacting with KMnO4, only the Fe2 plus that was formed is reacting. Fe2 plus form is reacting. Understand? So like that, they have given the information regarding the procedure. We have to understand that and do. So first thing they are expecting us to do is balancing all the chemical reactions happening. Okay, balancing all the chemical reactions happening. So one reaction they have already given. So I'll put that one in the board. So that reaction is the reaction between Fe3O4 and I minus. So Fe3O4 and I minus reacts to form 8H plus is needed to form 3Fe2 plus and 4 water and 1 I2. Now let's balance the other one, because with I minus not only Fe3O4, no, Fe3O2 also reacting, no? So the other compound is also reacting. You have to understand that, right? So let's balance the reaction with the other compound, Fe2O3 and I minus. Now this is a redox reaction. Okay, so now I'll remind you the method. So Fe goes to Fe2 plus. So since there were two Fe ions, here. So it will give you 2 Fe2 plus. And here it's going to give you I2. Then there are 2 iodine. So let's put 2 in front of here. So before start balancing, you need to balance atoms. Okay, you need to balance atoms before going any further. Then take the oxidation numbers. Now here, iron was in +3 oxidation state. No? So there were 2 such ions, no? Right? So then cumulative oxidation number is +6. Here it was -1. There are 2 I minus ions. So cumulative oxidation number is -2. Here +2, +2 into 2, +4. Here it is 0. 0 into 2, 0. So now you can see cumulative oxidation numbers. Then let's write down the balancing. Electron exchange here from +6 to +4, it gained 2 electrons to reduce. So to oxidize from -2 to 0, it loses 2 electrons. So now 2 electrons lost, 2 electrons gained. So it's balanced, right? It's already balanced. You don't need to multiply. No need to multiply. So you can keep it in the same way, right? Then what you need to do is balancing the charges. Remember? So in this side, the charge is left side. So right side, the charge is 2 into 2 plus 4. In the left side, you have a charge of -2. So to balance that charge, you need to add 6H plus. 6H plus. Then in the other side, you need to add 3 water. Now you can check oxygen to make sure that is whether it is balanced. Here in the right side, you have 3 oxygen atoms. In the left side also, you have 3 oxygen atoms. So it is balanced. It is balanced. Understand, Namit? So that's how you balance the redox reaction in this method is called what? Oxidation number change method. Okay, with a minimum effort, we can balance this. Right? So now we have how they are reacting. How they are reacting. Okay, so for writing this reaction, you will get marks. Okay. Right, or you can balance this one using Fe3 plus also. Right, Fe3 plus reacts with I minus, goes to I2 and Fe2, Fe3 plus, right? So this way also accepted, you have to balance it, right? But however, right, because the example they have given in this way, no? So writing the same format is better. Therefore, try to balance it in the earlier way. Understood that, Kanaman, about the balancing. Then let's see what should be done next. Now, so in previous day also we did 2 chemical calculations essays, 2021 and 22. So while doing those questions also I advised you, if there is a mixture of compounds, we have to take one compound moles as Xn and the other compound moles as Y. Oh, you can take N1, N2, like that, anything you like, okay? So by getting that one, you can go to the other compound moles, other ion moles, right? So that's the way we have to start. So here also, let's start by doing, okay, by labeling Fe3O2 and Fe3O4 and Fe2O3 moles by taking them as X and Y. Understand? So now let's say you have X moles of this one and then you have Y moles of this one. You can take N1, N2 also, any symbol you prefer, okay? But you have to define it before start the question, right? Before start the question, you have to write in words. Fe3O4 moles are Xn and Fe3O4 moles, sorry, Fe2O3 moles are Xn and Fe3O4 moles are Y. Like that, you have to start by telling that. Okay, so let's say now, according to these balance equations, now the ratios are 1 and 1. So from 1 Fe3O4, you get 1 I2. From 1 Fe2O3, you get 1 I2. Understand? So here, then you will get X and Y moles of I2. X and Y moles of I2. Understand? X and Y moles of I2. Then, then think about Fe2 plus. Now here, if it is 1, you get 3 Fe2 plus, no? Isn't it? So that means 3x. 3x of Fe2 plus. So what about Fe2 plus in the second equation? Yeah, no, I missed that here, no? If from Fe 3O4, you will get 3Y. 3Y. Okay, from Fe2O3, you will get 2X here. Okay, because I balanced this last two. Can you see that? Like that, we can understand how much Fe2 plus and how much I2 was there. Okay, so then that Fe2 plus and I2 is titrated against these two reactants. So that's the way you have to go with the question. Is that clear, Lama? So it's a very good question. Nah? So basically all the past paper essays came from chemical calculations is good. Okay, so next week we'll do 2024 and after that week we'll do 25. Like that we'll continue. Okay, so all the questions are very interesting. Okay. So you have to kind of memorize and kind of repeat those questions again and again and again. Okay, we'll see. Yeah, now let's start the questions. I'm going to erase this balancing. Okay, so you need to write down about how to balance this first reaction. And not only that, you have two other reactions to balance. The reaction between sodium thiosulfate and I2 and the reaction between KMnO4 and Fe2 plus. Okay, after erasing this thing, I'm going to balance that too. So I hope you understood well. Okay. Right. So shall I erase? Okay. Now let's balance the reaction between I2 and sodium thiosulfate. So you can neglect sodium, right? And here it is. You can write I2I minus and S4O6 2 minus. So this reaction you need to remember, no? Isn't it? Sodium thiosulfate goes to tetrathionate ion. Tetrathionate ion. So here you need to put 2 in front of this one, then it get balanced. So the ratio is 1:2. So after you finding the sodium thiosulfate moles, you have to divide that one by 2 in order to find how much I2 was present. Is that clear? Okay, so shall we do that part here in the question is almost done. Otherwise, we have to write this again. Isn't it? So after that, we'll go to KMnO4. Okay, Lama? We'll do like that. So now let's find out moles of sodium thiosulfate. Okay, so I omitted sodium. Okay, so 0.5 mole per decimeter cube is the concentration, and the volume is 15 cubic centimeters, 15 into 10 to the power minus 3 decimeter cube. Okay, so you can say 7.5 into 10 to the power minus 3 moles. Right? Then you can write the ratio between I2 to sodium thiosulfate is 1:2. So therefore you can find moles of I2. But this moles of I2 presenting 25 cubic centimeters. Don't forget that one. Huh? It is there in 25 cubic centimeters. Remember that well. Okay. So 7.5 into 10 to the power minus 3, you have to divide by 2. So that means, well, it's keep it in that way without simplifying. Or you can just simplify, no problem. So half of that moles will be there in 25. Now, but we are focusing, we wrote this x2x and 3yy for the 100 cubic centimeters. That's where the diagram is important. So when you draw something, right, it always there. No? So you are seeing that one. So you are not going to do any accidental mistakes. Okay, because you are seeing the diagram. So now let's come backward from 25 to 100. Okay, let's come backward from 25 to 100. Okay, so what should we do? So now we are going to find how much moles were there in 100 cubic centimeters. So in 100 cubic centimeters, what should we do? Into half into 10 to the power minus 3. This was the moles in 25. So now it is you're coming backward because this was a dilution, sorry, separation. So the moles are increasing if you come backward. So you divide by 25 and multiply by 100. So I'm seeing how much will be there for the 100. Okay, so that means it is coming as pawn. That's why I didn't simplify. So then this one will be cancelled. Isn't it? When you are cutting these things in the A level, use a pencil, okay? And then again 15 into 10 to the power minus 3 moles are out. Now that means you have found what? X and Y addition, no? X and Y addition, no? So then you can write this equation. What is that? X plus Y equals to 15 into 10 to the power minus 3. This will be your first equation. So we're going to form another equation using simultaneous method. Okay, another equation that include X and Y with the help of Fe2 plus. Okay, we're going to do that later. Okay, first of all, let's write down this and understand it well. Is that clear now? Sodium thiosulfate, you need to write the reaction. Then get the sodium thiosulfate moles. Then find how much I2 was formed in 25. But I2 was originally there in 100, so come one backward. Okay, so that means this much of I2 moles are there in 100. Then that is equal to X plus Y. X plus Y. So if you assume initial compound has Fe2O3 X moles and Fe3O4 Y moles, then equal moles will be given as I2. We saw that one in earlier two balanced equations, right? I know that is clear. Good. So finish that part. So we have one equation. I'm going to write it here. X plus Y equal 15 into 10 to the power minus 3 moles. That's our first equation. The mole you can ignore. Okay. Shall I erase this part? Give me a minute. Yeah, then the other part is, hope it is clear. Then the other part is the reaction between KMnO4 and Fe2 plus. KMnO4 and Fe2 plus. KMnO4 and Fe2 plus. Yeah, so Fe2 plus reacts with MnO4 minus. Now, this is happening in acidic medium. So it mentioned acidic medium. So now it's already having a dilute H2SO4. That means it is acidic medium. So that means Mn2 plus will be formed and iron will be oxidized to Fe3 plus. Right? So this reaction we have balanced several times, right? So first of all, get the oxidation numbers. +7, +2, and +3. Then the arrows. Now this is undergoing reduction by taking 5 electrons. This is undergoing oxidation by losing 1 electron. So to balance electrons, we need to multiply this one by 5. 5. That means you need to put 5 in front of Fe2 plus and 3 plus. Right? Now the electrons are balanced. Now you have to balance the charges. In the right side, you have 5 into 3, 15 plus 17 charge. In the other side, you have plus 9 charge. Because 5 into 2, 10. 10 minus 1, 9. Plus 9 and plus 17. So the gap is 8, no? So you had to add 8H plus here. 8H plus here. 8H plus here. So that means 4 water. Then you have to check oxygen to see whether this was balanced properly. You have 4 oxygen atoms here and 4 oxygen atoms in the other side. So it is balanced. That's the way. Okay, so now this equation shows us the ratio between Fe2 plus and KMnO4 is 5:1. 5:1. So now let's start like earlier part. Let's start from the moles of KMnO4 and go back. Okay, and go back. So now let's find out moles of KMnO4. Moles of KMnO4. Or MnO4 minus, right? So 0.25 mole per decimeter cube. multiplied by 14 into 10 to the power minus 3 decimeter cube. Okay, so 0.25 means 1/4. No? 1/4. So basically you are dividing this one by 14 divided by 4. That means 7/2. 3.5 into 10 to the power minus 3 moles. Right? So then you can show the ratio. The KMnO4 to Fe2 plus ratio is 1:5. Therefore, Fe2 plus moles. Now, how much volume you separated? 50. That's also important to note, because if you accidentally took it as 25, then the whole thing is going to get wrong. Okay, so Fe2 plus moles in 50 cm cube is, you're going to multiply that one by 5. 3.5 into 5 into 10 to the power minus 3 moles. Right? And then you're going to check how much will be there in 100, because this Fe2 plus was first present at 100 cubic centimeters. Okay, so now let's find out Fe2 plus moles in 100 cm cube. So 3.5 into 5 into 10 to the power minus 3 moles were there in 50. Now how much will be there in 100? Divide by 50 and multiply by 100. That means 2 times, right? So 7 into 5 into 10 to the power minus 3 moles. That means 35. 35. 35 into 10 to the power minus 3. Understood? So this will be equal to what? This will be equal to 2x plus 3y. Then that's the total Fe2 plus moles. 2x plus 3y will be equal to 35 into 10 to the power minus 3. So that will be our second equation. Okay, now I'll write it here. 2x plus 3y. Okay, so now we can simplify and find out x. Let's do that one here. So I'm going to cancel 1. So I suggest you to multiply y. So let's multiply first one by 3. So then it becomes 3x plus 3y equals 45 into 10 to the power minus 3. Okay, let's label it as 3, third equation. So now you can subtract second equation from the third one. The second equation is 2x plus 3y. 2x plus 3y. So when you're subtracting, x will be remaining as the answer. Okay, y getting cancelled, 1x is remaining. So x is equal to 1.0 into 10 to the power minus 3 moles. That is the moles of Fe2O3. Okay, so if you know x, then you can find y. Okay, so therefore y will be equal to, here is 10, no? 10, sorry. 10 into 10 to the power minus. So you're going to subtract 15 minus 10 into 10 to the power minus 3, which is 5 into 10 to the power minus 3 moles. This is the moles of Y. That means ferrosulfuric oxide moles. Now they are asking the mass percentages. No? That's the final question. They have given the molar masses of oxygen and iron. It's a very simple thing to do. But first of all, see whether you understood up to this level. Okay, so what you have to do next is simply multiply that number of moles by their molar masses, and after that finding that mass, divide it by the total and get it to the 100%. Okay, now we know how much two compound moles are there. So let's find out molar mass of Fe2O3. So 2 iron atoms, 56 into 2 plus 16 into 3, 48. 48 plus 112, 160. 160 grams per mole. And then we can find mass of Fe2O3. So let's multiply this one. Fe2O3 is x, no? X was 10 into 10 to the power minus 3. So 10 into 10 to the power minus 3 moles into 160 grams per mole. So it is 1.6 grams. Then you can find Fe2O3 mass percentage. 1.6 grams are there from 3.2 grams. then into 100%. So it's exactly 50% is there. You have to follow the same procedure to find the molar mass of Fe3O4, which is 56 into 3 plus 16 into 4. Right, so it is 150, 168, and then 68, and 16 into 4, 32, 64, 12, 232, 232 grams per mole. Then let's find the mass of Fe3O4. So multiply that moles, 5 into 10 to the power minus 3 moles into 232 grams per mole. Yeah, you can divide this one by 2 and see. 1, 1, 32, that means 60. Sorry, 12, you have 6. 116. So the answer is going to be 1.16 grams. 1.16 grams. Okay, so then you can find out the Fe3O4 mass percentage. So 1.16 grams divided by 3.2 grams into 100%. Okay, into 100%. Yeah. So it is not exactly divisible. You have to find it out for yourself. Right? So let's simplify as much as possible. Okay. So 116 divided by 3.2. Say 1600. Simplify it a little bit more. Divided by 32. So you can divide this one by 4. So then it will become 8. Here, let's see whether we can divide by 4. Yeah, 116, yeah, it is divisible by 4. So for 11, you have 2. Then you have 36, 29, 290. Okay, now 290, let's divide by 8. You have 3, 24. Then you have 5 remaining, 50. You have 6. Then it is 48. Then you have 2, 20. You have 2, and 16, and yeah, 36.25. That is the mass percentage of Fe3O4. So don't just subtract it from 100%. Huh? So because there is an inert substance, no? There is an inert substance, no? Okay, so that's the way how you do 2023 A-level. If I summarize quickly, so what was there? There were 2 compounds, Fe3O2 and Fe3O4, right? So Fe3O4 is somewhat not that commonly we have heard. So, but anyway, that compound is a mixture of 2 compounds, mixture of 2 oxides, Fe2O3 and Fe2O3 and FeO. Both oxides are there. Okay, and then first they are telling it is reacting with I minus. So when it is reacting with I minus, it's a very good question. See, all the I minus that are reacting goes to I2. Okay, and all the Fe, which was there inside that compound, converts to Fe2 plus. Okay, so now in this compound already some Fe2 plus was there, and it is also converting to Fe2 plus. So don't worry, it is already balanced. They have already given a balance equation for this one. You only have to give a balance equation for Fe2O3, right? So after getting those equations, you can see, right? If you have x moles of Fe2O3, you will have 2x moles of Fe and x moles of I2. So this is not the balance equation. We did that one earlier. And according to the same way, from Fe2O3, if you had y moles, you have 3y moles of Fe and Fe2 plus and y moles of I2. So those are the moles of I2 and Fe2 plus present. Now that was diluted to 100 cubic centimeters. Okay. Then from that 100 cubic centimeters, they are separating 25 and 50 to analyze. So from the portion of 25, they are analyzing how much I2 was there by reacting with thioside. And from that 50 portion, they are analyzing how much Fe2 plus was there by simply reacting that one with KMnO4. Understand? So here there is no reverse titration, no anything in any of those theories included. Only the separation, dilution, and acid dilution and redox reactions. Those are the theories that are included. So it's a kind of possible question that we all can do, isn't it? So get familiar with the question patterns, do more questions, and you'll get better with the practice. Okay, Lamai? Right. Now let's go now to the MCQ part of that paper. MCQ part of that paper. Okay, so let's start with the first question. Which of the following species shows a linear shape? Linear shape. So there are 5 molecules given. So it's asking molecules and ions given. They're asking which one has the linear shape. Now you can just draw them and see, or you can think and get the answer also, right? If you have enough practice, right? Without even drawing, you can take the answer. Okay, because kind of you can think and arrange the structure. Okay, so linear shape is there in 2 instances. Linear shape is coming in 2 instances. First one is, let's say you have 2 VSCPR pairs. Then the electron pair geometry and shape both will be linear and linear. Okay, and there's another instance it is coming in where you have 5 electron VSCPR pairs. Then if you have 5 VSCPR pairs, electron pair geometry is trigonal bipyramidal. In trigonal bipyramidal also, if you have 3 lone pairs and 2 bond pairs, then the shape is going to be linear. That's the way. Those are the 2 possible options. Now here, none of the compounds are having two VSC pair option. Okay, you have the other option to consider here for this question. Okay, so if you have simply, if you have carbon dioxide, then if you have BeCl2, then those are the 2 VSCPR pairs, linear electron pair geometry and linear shape option. Okay, so those compounds are not present now. Only you have the others. Right? Now the answer for this question is I3 minus. Okay, so let's draw it and see. So you have 2 iodine atoms perpendicular in the perpendicular plane, and then there will be 3 lone pairs. 3 lone pairs. See? 1, 2, 3, 4, 5, 6, 7, and 8. And here you have a negative charge. So this is I3 minus to the structure with the lone pairs. So this one is linear shape and linear shape and trigonal bipyramidal electron pair geometry. So answer is answer 2. Answer 2. So let's see how many of you got that answer. Yeah, 4 of you got the answer. Some of you have accidentally selected O3, ozone also. Okay, I'm going to show you the shapes of the other molecules, O3 and the rest. So ozone, O3. So it is a molecule like this. Remember, when we discuss resonance theory, we use this molecule, right? So there is a lone pair. So it's going to be angular shape, angular or bent or V shape, you can say. It's not linear. Then you have ClO2. Now, for a molecule like ClO2 minus, you can easily draw the structure because for chlorine, you have 7 valence electrons. From that 7 valence electrons, oxygen is making bonds with 3 of them because the negative charge should be there also with 1 oxygen atom, right? So then you subtract 2 electrons for the double bond oxygen. Then you subtract 1 oxygen for the single bond oxygen with negative charge. Okay. And then how many electrons remaining? 4 electrons are remaining. 4 electrons exist as 2 lone pairs. Then you have 4 repulsion units, no? 2 bond pairs and 2 lone pairs. So this will be the structure. See? Then what is the shape again? This is also angular or bent shape, but with a different angle than ozone. Okay, ozone has an angle somewhat less than 120, but this one has an angle somewhat lesser than 109.5 because the electron pair geometry is different. No? Even though we give the same name, angular or bent, angles will be different. But here angles are same, 180, 180, linear. Okay, bent. There are 2 other molecules, SO2, which is again bent. This is the structure. There's 1 lone pair. And then NH2 minus. NH2 minus, there is a negative charge on nitrogen. It's also bent. So all these other molecules are having bent shape. Bent shape. Okay. So answer is answer 2. Good. Most of you didn't. Okay. So those who got wrong, please try to read it. And explain why the answer you selected is not coming. Understood, Lama? Then go to the second one. Select the correct statement. There are 5 statements. Let's analyze them and see what is the correct statement. Then let's write why others are wrong. Since the electron pair geometry of COCl2 is trigonal planar, its all bond angles are exactly 120. So that statement is wrong. Why? Because if it is COCl2, this is the structure. So telling exactly 120 is wrong. Because you can see, now this carbon-oxygen bond is short. Okay, carbon-oxygen bond is short and it is having more electron density. More electron density because it's a double bond. So then it can repel other electron pairs. So it can kind of push this down. Then as a result, this angle would be greater than 120. This angle would be lesser than 120. Understand? Less than 120. So therefore, you can't say exactly the angles are 120. So if it is a molecule like BCl3, BF3, no, then that is correct. Exactly 120. All angles are 120 because repulsion units are symmetrical, no? But in there, it is not that symmetrical. Double bond exerts more repulsion on other single bond pairs, single bonds. Is that clear, Lama? That is, I hope it is clear. Yeah. Then let's go to the second statement. Second statement is telling the increasing order of first ionization energy, fluorine, lithium, carbon, sodium, oxygen, they have given a certain order. Let's say sodium, lithium, oxygen, carbon, fluorine. So now for these two, that is correct because sodium is a down in the same group lower period element. No? So when sodium is having a higher radius, so it's very easier to remove electrons from sodium. Okay, than lithium. So group 1 elements are having usually low ionization energy. So you can tell that one. They are in the group 1. So therefore, they have ionization energy lower first ionization energy. Then the problem is with these two. Okay, this one. So let's draw it and show. Here you have fluorine. Here you have oxygen, nitrogen. And carbon is right here. Understand? So carbon is not going to be higher than oxygen. Understand? Oxygen had a lower value because because nitrogen had a relatively higher value, no? Because of the stable configuration. That's the only reason. Okay, so that doesn't mean oxygen is having a lower value than carbon. Understand? Why? Because oxygen, it is having more nuclear attraction. More effective nuclear attraction is there. Therefore, it can't be lower than carbon. Understand? Because of this is wrong. Therefore, this statement is going to be wrong. Okay, so that's the problem with the second state. Then you can go to the third one. All possible Lewis structures of SCN minus are equally stable. SCN minus, a common question. No? This was there in your tutors. We draw this one in the class. SCN minus Lewis structures are not the same. These are the three Lewis structures you can draw for SCN minus. You can draw them and show. So you can see they are not equal. So what is the most stable one? This one is the most stable. Stable. Then this one is unstable because more electronegative charge, more electronegative element. Sulfur is not the more electronegative one, even though it has a negative charge. Okay, this was stable because electronegative nitrogen has the negative charge. This one is the more unstable one. Why? Because there is a charge separation. Charge separation is high. So you can't say they are equally stable. Understand? They are not equally stable. If you take carbonate, CO3 2 minus, then there are three equally stable resonance structures. If you take ozone, then there are two equally stable resonance structures. You can check the tube and see. So that's what meant by equally stable. So here it is not equally stable. You can find this one in the resonance section, okay? Then go to the question, statement 4. Now all those three statements are wrong, right? And the fourth one, among H2O, CH4, CH3 minus and CH3 plus, the largest bond angles are there in CH3 plus. That one is correct. Okay, because if you draw water, its bond angle is, you know it from biology also, it is 104.5 degrees. And then from CH4, it is 109.5 degrees. Then from CH3 minus, that means there is a lone pair. So it's going to be 107 degrees, like ammonia. And then finally you have CH3 plus. CH3 plus means only 3 repulsion units are there. So now the bond angle is exactly 120. So this is a larger value. So the fourth statement is correct. That's our answer. Okay. So last one, OF6 and SF6, both are stable and octahedral shape. Now, SF6 is octahedral because there are 6 repulsion units, but OF6 does not exist. Right down there. Fifth one is wrong. Why? OF6 cannot exist. Why it cannot exist? Because oxygen can't violate the octet rule. We can write that too. Cannot violate octet rule. So it cannot violate the octet rule. So therefore, that one is also wrong. Understood, Lama? So that is your answer. It's kind of like discussing 5 MCQs. It's very valuable. So study that well. So let's go and see how many of you did that one. Okay, very good. Very good. 6 of you have taken the answer. Correct. Good. That means there's a clear improvement in those who are answering. Okay. Right. And look at the third one. Again, it is asking correct statement. It's about unit 1 theories. So de Broglie wavelength. The first two statements are based on de Broglie wavelength. De Broglie wavelength formula is lambda equal h over mv. Mass into velocity. Okay. Or speed. Then de Broglie wavelength associated with H2O molecule is shorter than in sodium, neon. That means de Broglie wavelength is H2 is shorter than de Broglie wavelength of neon. So this one is heavier, no? Sorry, lighter, no? Neon is the heavier one. So if mass is higher, de Broglie wavelength is going to be lower. then that statement is wrong. Understood? That statement is wrong. What should be the actual? De Broglie wavelength of hydrogen is larger. This is the correct one. Understood, Lama? De Broglie wavelength of hydrogen is larger. Okay, because if it is lighter, then de Broglie wavelength should be higher. So look at the second one. It says the helium traveling at 2 into 10 to the power 5 is longer than the 2 into 10 to the power 4 speed. Yeah. Now again, lambda equal h over mb. So if the speed is lower, de Broglie wavelength is higher. De Broglie wavelength is higher. Or the speed is higher, de Broglie wavelength is going to be lower. Okay, so the one that travels with 2 into 10 to the power 5 should have a lower de Broglie wavelength than 2 into 10 to the power 4 traveling helium atom. Understand? So telling that longer wavelength for this one is wrong. Okay, Lama? So second one is also false. Now look at the third one. The energy of a photon associated with infrared waves is larger than X-rays. So that's completely wrong. Why? Because infrared, you can say frequency of infrared is lower than frequency of the X-rays. Okay, so then you know this one from the Planck equation, H nu. So therefore this one is having higher energy. Higher energy. Okay. In the fourth statement, fractions of photons can be absorbed. No. So it's wrong. You can write for your review Planck's quantum theory. So in Planck's quantum theory, you have 3 points. Okay, what are the 3 points? First one is energy absorbed or released as energy packets. Okay, energy is quantized. That's the first point. And the second point is energy packet. One packet energy is given by this equation equal h nu. And the third point is that the one that given here, as mentioned as wrong actually. So the actual correct one is energy can't be absorbed or released as fractions of packets. Always energy absorbed or released as whole number multiples of packets. Let's say 1 packet, 2 packet like that. That's how they release or absorb. They can't absorb fractions or they can't release fractions. That's the point. Okay. So then the 3 points are, first one is energy quantized. And then this equation. And then no fractions. Okay. Then fifth one must be correct. Let's see why. Photons are having same frequency, may have different wavelengths. That's true. I'll explain. During bending, let's say light rays, when going from one medium to another, its speed changes. So speed of a wave is equal to V equal frequency into wavelength, right? So they must keep the same frequency, because depending on the frequency, color is decided. So let's say red color is going from water to air. Okay? Then it's bending like this, no? But the same red color is there. That means same frequency. Same frequency. 650, same frequency. Button, it will change the speed, no? Okay, speed changes. Therefore, with the speed, what is going to be changing? Wavelength is changing. Okay. since frequency must be constant, wavelength is changing. So this is called refraction, bending of light rays. Refraction. During refraction, this happens. Understand? So anyway, it's no problem, right? Because you can obviously see other four statements are wrong. So then fifth one must be the answer. Is that clear, Lama? The third question, let's see how many of you got that correct. Third one, yes, good. Good. Okay, so now let's go to the fourth question. The oxidation numbers, it's a very easy one, right? You can use mathematical method to get the answer easily, right? CrO4 2 minus, oxidation number is +6. And then NO2 minus and CO3 minus, SO3 2 minus. Okay, I'll do that. CrO4 2 minus. So now I'll show you the mathematical method. Let's assume this as X. So for oxygen, you have a fixed oxidation number. Generally, it is fixed, having a -2. So -2 into 4 equals to -2 overall charge. Okay, so sum of the oxidation numbers of the ion is equal to the charge. Okay, so x minus 8 equal -2, then x equal +6. Okay, so if you follow the same way, you will find NO2 minus oxidation number is +3. Then CO3 2 minus is oxidation number +4. And a similar structure for SO4, SO3 2 minus. That is also +4. Okay, so +6, +3, and 4, 4. Answer is answer 3. Okay, let's see how many of you got that answer correct. Yeah, okay, all of you did that one. Very good. Then let's go to the next one. About valency and oxidation state, valency and hybridization of NO2F. First of all, get the Lewis structure. This is the Lewis structure of NO2F. Okay, so nitrogen is having a plus charge. Then the oxidation state you can simply easily find. Okay, even from mathematical method and the structure. Oxidation number will be +5. Okay, so you can draw the dipole moments. Here you can say nitrogen lost 4 electrons partially. So that partially electron losing you can see with the arrows. And with the positive charge you can say lost 1 electron total. That's why the positive charge is coming. So altogether it loses 5 electrons. That's why oxidation number become +5. Okay, then what is this valency? What is this valency? Valency, number of electrons participated for bonding. Okay, of that atom, out of the total electrons, how much of the total electrons are participating for bonding? That's what meant by the valency. So now for you to get a clear understanding, otherwise you will select there are 4 electrons. That's actually wrong because nitrogen was having 2, 5. There were 5 electrons in the valence shell according to the O levels, right? So now we write it like 1s2, 2s2, 2p3. So these 5 electrons are participating in bonding. Can you see any remaining electrons here? No. All 5 electrons are participating. All 5 are participating. It has made only 4 bonds, but 5 electrons are participating. So how you can prove this one? Okay, so to show that, you have to go to the dot cross diagram. That's the only place you can show. Okay, so here dot cross, dot cross, dot cross. With the dots, I am indicating the electrons of nitrogen. So here you have the double bond, and where are the other 2 electrons? Other 2 electrons are there with the oxygen. This is structure. This is the dot cross diagram. Can you see now the 5 electrons where they are located? So now that means this bond, this bond, I draw that one again. This bond right here is what? A dative covalent bond, isn't it? Dative bond, dative covalent bond. So both electrons necessary for the bond is given by nitrogen. So therefore nitrogen has participated all of its electrons for bonding. Is that clear nicely? So valency will be 5. Okay, so now these questions are not that commonly asking now. But still, for your school's test, these things can be there. So study that well. Understood? So there are 5 electrons participating. And the next one, about the hybridization. So hybridization is sp2. sp2 hybridization, because why? Because the electron pair geometry is trigonal planar. Okay, so trigonal planar. Therefore, hybridization will be sp2. Because you can see one 5 bond is participated, one 5 bond is there. To make that 5 bond, a p orbital should be relieved. Okay, so other 2 p orbitals and the s orbital is participating in sp2 hybridization. Okay, so you can write one p orbital is left for 5 bond. Okay, so other orbitals are hybridized. So answer is going to be what? 5, 5 and sp2 answer is answer 1. Let's see how many of you got that answer. Question number 5. Yes, okay, good. Majority of you has get that answer. Some of you have selected answer 5 also. Yes, that valency problem is there. So study that part, okay? It will be fine. Right. Now let's go to the question number 6. Question number 6. Which of the following statement is correct regarding the given periodic property within the bracket? Radii, first electron gain energy, okay, second ionization energy, and number of unpaired electrons. Number of unpaired electrons. Okay, so I'm going to explain that one. See after that what are the answers, okay? So if you go to the radii, so Br minus bromine, Br minus, it is in the 4th period. 4th period, yes, because fluorine, bromine, iodine. So this is in the 2nd period. Okay, so our fluorine is there in the 3rd period. This one will be there in the 4th period. So 4th period, and there's a negative charge also. Therefore, it must be the largest, no doubt. Okay, and then you have sodium, silicon, sulfur. Sodium, silicon, sulfur are 3rd period elements. So that is also correct. Because why? Towards the right side. These are all third period elements. Across the period, radii decreases. Why? Because the nuclear charge increases now. Nuclear attraction increases now. As a result, radius decreases. Okay, so sulfur is the one with the smallest size from those three. And then the other one is also correct. Why? Boron. Boron is in the second period. So second period, boron is smaller. Okay, boron is smaller. So that's the answer. That is correct. Okay, A is correct. It's ABCD1. So A is correct. Then look at the next one about first electron gain energy negative value. So negative value means the how much energy that they are releasing. Okay. So the out of the four elements, the minimum energy is released by potassium, then phosphorus, then silicon. Largest energy is released by sulfur. The potassium thing you may not know, but okay, that button for the A-level exam, this part can be come because we know carbon, nitrogen, oxygen. This order follows. No? Nitrogen is having a lesser electron affinity because it's having this stable electronic configuration. No? Stable 2s2, 2p3 configuration. A similar pattern is shown by silicon, phosphorus, and sulfur. Phosphorus is having a negative value, but lesser negative value, lesser magnitude. Or we can say less exothermic. Understood? Because of the stable configuration. This is kind of a similar pattern. Potassium, you might get confused, but just imagine potassium is a metal. So metals are usually sodium, potassium, those are having lesser affinities. Okay, because the radius is higher. So electron affinity, let's call it as affinity, it's easy. Electron affinity decreases downward the group 1. Okay, so highest affinity is there for lithium. Then sodium, potassium, rubidium, cesium. Cesium is the one with the lowest affinity. Remember that. Affinity means gain energy negative value. How much energy released. Okay, so then you can just argue and think. Okay, I'm not going to get confused, okay? This statement is false. Then what's with the statement C? Second ionization energy. Sodium largest, then fluorine, then neon. Now that part is wrong. And you can easily get into the conclusion. Now earlier, first ionization energies were like this, no? Sodium, neon, fluorine, neon, sodium. Then for the second ionization energy, you have to come one backward. Remember, come backward. So then sodium comes here, sodium plus with a stable neons configuration. And neon comes here, fluorine goes to the place of oxygen. So the neon ionization energy is higher than fluorine. So telling that fluorine is higher is wrong. Sodium, fluorine, neon. No need to worry about the other part. This part is wrong. Okay, now. Then look at the other part. These statement. The number of unpaired electrons. First one, copper. Copper is having 3D 10 4s1. Therefore, copper plus 3D10. So no unpaired electrons. No UPE, unpaired electrons. Then the next one, vanadium. Vanadium is 3D3 4s2. Then vanadium 3 plus is 3D2. So then 2 unpaired electrons. And then cobalt 2 plus. This must be easy by now, okay? For you. 3 cobalt atom is 3D7 4s2, atomic number 27. Then cobalt 2 plus is 3D7. 3D7. So if you draw 3D7, these are the 5 orbitals. These 2 orbitals will be paired, then there will be 3 unpaired electrons. 3 unpaired electrons. So you can see it's gradually increasing. 0, 2, 3. Then is it correct? Fe3 plus. Fe3 plus. It's having Fe is 3D6 4s2. Then Fe3 plus. Fe3 plus 3D5. Because these 2 electrons and one of the D6 electrons are removing. So then you will be having 5 unpaired electrons. 1 per each orbital. So 5 unpaired electrons. So it's gradually increasing, right? Yes. 0, 2, 3, 5. So this statement is correct, B. So A and D are correct. Other 2 are wrong. So it's asking correct statements. Answer is answer 4. No? Answer 4. If A and D are correct, you have to select answer 4. Yeah, some of you had selected other option. Anyway, I hope now it is clear. Okay. Answer is answer 4. Right, the 7th question is also kind of easy. It's asking which can be considered as redox reactions. In a redox reaction, the theory is lamai, oxidation number is changing. Oxidation number is changing. Okay, I'll show you how to get the answer. You have to select in which equations oxidation numbers are changed. Okay, so these are the 3 equations, 4 equations. Sorry. First one, SO2 reacts with water to give H2SO3. So now here oxidation number is +4, oxygen -2, hydrogen +1, this oxygen also -2. So the same oxidation numbers exist here. So it is not going to be a redox reaction. Okay, so A is wrong. But if you take B, C, D, they are going to be redox reactions. So if you take B, potassium reacts with water to form KOH and H2. So what are the redox parts? Here potassium with 0 oxidation number, hydrogen with +1 oxidation number. Potassium goes to +1 and hydrogen goes to 0. This one undergone oxidation. This one undergone reduction. See? Then look at the next one. Magnesium and copper sulfate. See? Magnesium, copper sulfate. It becomes magnesium sulfate and copper. So oxidation numbers, magnesium 0, copper here you have copper 2 plus now. So then +2. This one magnesium 2 plus, +2 and 0. See? Redox. Oxidation, reduction. And the last one, D also correct. H2O2 goes to H2O and O2. In H2O2, it's an interesting molecule. Oxidation number of oxygen is -1. See? This electron is not exchanged, shared. Here, hydrogen, from hydrogen, it is attracting electrons more. So from -1 to -2 and 0. Same entity undergo oxidation and reduction. So this is called disproportionation. Same entity undergo oxidation and reduction. Okay, so our D is also correct. So answer is answer 5. Okay. To the answer script, I added that one. If you're selecting 5, which should be something exactly should be the answer. I added that one there. Yeah, majority of you have selected the answer 5. Good. Okay, so that's it about the 7 questions. And the other 5 questions are from gases, gaseous state lesson that we are discussing currently. I'll show you those 5 true-false statements too. Right. So look at the first one. Fusion. Fusion is endothermic. Okay. Right there, what is fusion? Fusion is converting solid into liquid. Solid to liquid. So it's in other words, you can say melting. Okay. So for melting, heat is absorbed. No, you have to give energy from outside. No? So it is endothermic. That's correct. Okay. That's correct. Melting is endothermic. Melting means solid to liquid. So it absorbs heat. Absorb heat to break attractions. Intermolecular attractions. Okay, so then first statement is correct. So this is your reason. Then look at the second statement. Heat is absorbed to break strong intermolecular attractions speed existing solids relative to liquids. Yeah, that's correct. And it can explain the first one also. Explains two. So therefore answer is going to be answer 1. Answer 1. If they explain, answer is answer 1. So I gave you this answer exact charts in that link I provided. Okay. So when you're answering, you can see that 10 mark. Then the second one or the 9th question. Pressure of an ideal gas is directly proportional to the absolute temperature. So what do you think? Pressure is directly proportional to the absolute temperature. Is that correct? So that statement is wrong. Why? Pressure is going to be directly proportional to absolute temperature when these things are constant, because pressure and temperature are affected by volume and moles on. Okay, so if volume and moles constant only, this will be correct. This will be correct. So therefore this statement is wrong, because it haven't mentioned anything about volume or moles, so it's going to be wrong. Okay, see, the pressure is, if an ideal gas is directly proportional to the absolute temperature of the gas. So it's wrong. It's a good statement, right? It will be directly proportional when volume and moles are constant. Look at the next one. For an ideal gas, PV equal nRT is applied. So that one is correct. So first one false, second one correct. Answer is going to be answer 4. Here answer was answer 1. Let's see how many of you got that 9 and 10, sorry, 8 and 9 questions correct. 8 question, majority of you have done well. Very good. And 9 question, okay, you have that also done. See? Very good. Let's look at the 10th question. Now, 10th question, you have 50-50. Some of you have selected answer 5. That means both statements are wrong. Some of you have selected answer 4. That means first one is false. Second one is correct. Let's see. Let's see what is the 10th question. When the temperature increases from 27 to 327, the volume of a given ideal gas sample become half of the initial. Volume of a given ideal gas sample become half of the initial. So now let's look at that statement. You can directly say this is wrong. Why? Okay, if you want to consider the statement, even if it is correct or wrong, you need to check the pressure is given. Okay. You can say pressure is not given. Pressure is not given. That is the first mistake they have done. But if let's say it is given the pressure, then this is going to be correct, no? So 27 Celsius means 300 Kelvin. 327 Celsius means 600 Kelvin. So when temperature doubles, volume is going to be double. So that again wrong. Volume is directly proportional to absolute temperature. So then the volume, if this volume is V, this is going to be 2V. It's not going to be half. It's going to be double. But anyway, the pressure is not mentioned. So anyway, first one is wrong. Then look at the second one. According to Charles' law, volume is directly proportional to temperature. No, that also wrong. Why? According to Charles' law, volume is directly proportional to absolute temperature. It should be absolute temperature. There is a one mistake. It should be absolute temperature. What is the other mistake? What is the other mistake? It should be absolute temperature. Other mistake is pressure and moles must be constant. There are 2 points that you can say this statement is wrong. So both are going to be wrong. Both are going to be wrong. You can't say that it is ideal gas not mentioned. That is not going to be a problem because anyway Charles' law is defined for ideal gases. No? So when they say Charles' law, ideal gas thing is included. Okay. Right? So someone can argue pressure and moles are included. Also that is okay, but anyway they haven't mentioned about temperature. No? Must be absolute temperature. That means Kelvin temperature, not proportional to the Celsius temperature. Okay. So both are wrong. Answer 5. Answer 5. So some of you had selected that one. Good. So those who selected answer 4 should have a good understanding now. Okay. And look at the 11th question. 11th question. Density of an ideal gas is directly proportional to the pressure of the gas. Density directly proportional to pressure. Let's see how many of you got that answer. 11th one, answer 4. First one wrong, second one false. Second one correct. Now some of you got both are correct. Yeah. So now let's see how to answer that one. 11th question. So density. Density is mass over volume. Let's start with this one. PV equal nRT. PV equal simple M over capital M RT. So then you can say PM. I'm putting that M here. M over V RT. M over V is the density. PM equal DRT. See? Now if you subject density equal PM over RT. So if you are going to compare that with pressure, density is directly equal to MRT into P. Okay, so when you want to say of an ideal gas, M is constant. An ideal gas. Direct proportional to pressure, then this is false. Why? You can say temperature is not mentioned. Temperature must be constant. Then only this is going to be correct for a given sample. If you are comparing 2 gases, then you must say mass or molar mass also. Okay, so what about the second statement? At STP, standard temperature pressure is 0 Celsius, standard pressure is 180. N2 and COR gases have nearly similar densities. Nearly similar, okay, they are not telling same. Because why? So now the temperature and pressure is mentioned. Temperature and pressure are mentioned. So density then depending on the molar mass. Check the molar masses of this one. Molar mass of N2 is 28. Molar mass of carbon monoxide is also 28. 12 plus 16. Okay, so therefore, densities are nearly density of N2, density of carbon monoxide should be nearly same. But why the nearly comes? Nearly word comes because they are not ideal. That's why. That's why nearly that word is there. Okay, so answer is going to be answer 4. Second statement is correct. Answer 4. Let's see how many of you got that answer. 11th question. Yeah, okay, majority of you have taken. And the last question also, yeah, most of you got the answer, but some of you have selected other answers also. Now let's see the last statement. At extremely low pressure, at extremely low temperatures, ideal gases can be liquefied. No, ideal gases cannot be liquefied at all. Okay, why? Ideal gases cannot be liquefied because there are no intermolecular attractions. Understand? There are no intermolecular attractions, therefore you cannot liquefy ideal gases. So to a question, first statement is false. There are no intermolecular attractions for ideal gases. No IMA in ideal. So therefore cannot be liquefied. Because in a liquid, attractions are there. Okay. So you can't liquefy ideal gases at any condition. Okay. And then look at the next one. At low temperature, kinetic energy of gas molecules are lower. Intermolecular attractions become stronger. Yeah, this is just gas, no? Then it is correct. They are not mentioning ideal. For real gases, this is true. For real gases, this is true. So answer 4 again. First one in false, second one correct. Yeah. So most of you have taken that answer. Good. Understood, Lama? Okay, now I hope you got a better understanding. We did a chemical calculation essay at first. Then we did 12 MCQs, including questions from Unit 1, 2, 3, and Unit 4 also, the current lesson that we are doing. Now write a good review for this one. Write a good review and show that one and get marked.